So now our next topic is dielectrics and polarization. So in a dielectric, under the effect of an external field, a net dipole moment is induced in the dielectric. Okay, so this is a dielectric slab and this is an external electric field. So due to that external electric field, a net dipole moment is induced in the dielectric. So due to that, a net dipole moment is induced in the dielectric. Due to molecular dipole moments, a net charge appears on the surface of dielectric. Due to a molecular dipole moments, a net charge appears on the surface of dielectrics. See, this is a negative charge, positive charge on the surface, okay? These are on the surface. These induced charges produce a field opposing the external field. So these induced charges produce a field opposing the external field. That means the external field is in this direction. You can see the external field is in this direction, while this field induced inside the dielectric is in the opposite direction. So this induced field is lesser in magnitude than the external field. So E0 is greater than E inducing inside. So E0 is greater than E inside. So field inside get reduced. So the field inside, that is this electric field inside the dielectric gets reduced. So just remember E0 is greater than E in, that is E inside. So the formula is like E equal to E0 minus E in, where E equal to a resultant field. A resultant field will be equal to external electric field between two plates, E0, this one, minus E in, an electric field inside the dielectric, because E0 is greater than E in. So E0 minus E in, that will be the resultant electric field. This is how you feel the resultant electric field. Now what is polarization? So let's look at it. The induced dipole moment developed per unit volume in a dielectric slab on placing it in an electric field is called polarization. We denote it by capital P. So the induced dipole moment. So when we keep in the dielectric slab, we place it inside electric field, right? So we place inside electric field this dielectric slab. So that time a dipole moment is developed, right? So that induced dipole moment developed per unit volume. The dipole moment developed per unit volume in an electric slab, in a dielectric slab, on placing it in an electric field is called polarization. So this is polarization. So let's say it again. The induced dipole moment developed where per unit volume in a dielectric slab. Why? How it is? On placing it. Okay, so how? On placing it in an electric field is called polarization. That is polarization. So P equal to NP, where N is the number of atoms per unit volume. So it is a dipole moment in developed per unit volume, right? So N is the number of atoms per unit volume, and P is induced dipole moment acquired by an atom. So NP, number of atoms, and induced dipole moment acquired by an atom. The product of these two will give the polarization P. So next is dielectric constant, that is K. So it is nothing, we also call it as relative permittivity or specific inductive capacity, and it is denoted by capital K or epsilon R. Okay, so it has we denote it by two things, that is capital K and epsilon R. So dielectric constant is relative permittivity or specific inductive capacity. So they might ask what is relative permittivity or what is specific inductive capacity or dielectric constant. These three are the same. So K equal to E0 by E. That is, it is a ratio of strength of applied electric field to the strength of reduced value of electric field on placing the dielectric between the plates of a capacitor. So E0 was that applied electric field outside, right? And E, what is E? E is E0 minus E in. So this E is got reduced, right? This E0 got reduced, right? So E equal to E0 minus E in. If E0 equal to okay, let it be 5, and E in will be always less than 5. Okay, because we saw it that En will be less than E0. So if it is 3, let it be 3. So what will be E? E will be 5 minus 3. So the value is 2. So E is less than E0. Always. E is always less than E0. So it is a ratio of, that is dielectric constant is a ratio of strength of applied electric field to the strength of reduced value of electric field on placing the dielectric between the plates of capacitor. So we place this dielectric on the plates of capacitor, right? Between the plates of capacitor. That's how we got this, all this, that induced electric field inside and all dipole moments, everything. So that is what dielectric constant is. Just learn all this. If you understand, then it's easy. Thank you.